Hello, AP Statistics students. Mr. Eicher here. Looking at mock exam number 1, FRQ number 1. As I encouraged you on this document, I encourage you to see if you can time yourself. Now, we made the questions. I've made some of these questions. My friend Jared Derksen, some others have made these questions. We don't know exactly how long they'll take, but we tried to estimate maybe it would take about 25 minutes. So do encourage you to time yourself and let me know if you finished really early. Let me know if you didn't finish anywhere near the time. That might be an issue if the question's too long. But my guess is on the AP exam, the questions will be very long, particularly the 25-minute question. They probably won't have a lot of time just to sit around and check your work. I think the College Board will make long questions to try to discourage students from completing the exam and then sharing their answers with someone. There will be a lot of penalties, I've heard, for students who are caught cheating. And I guess College Board has different tactics that they use. Also recommend that you have your one-page summary out. I would encourage you to try to boil things down to one page. You really don't want to be using a lot of your testing time to sift through a bunch of notes. If you're thinking that the AP exam is going to be easier because it's open notes, I wouldn't go there. I would encourage you to know the content as well as you can and try to answer all the questions that you can before sifting through your notes. You can have a calculator handy, but a lot of the information that the College Board has given out has said that a calculator isn't required. So because of that, we've tried to make questions that are not as calculator based. And I guess that's all I need to say. Okay, so let's look at the answer. We have a histogram here. First, I'd like to answer this question as if we didn't know any of this information. Because we know that information, it makes it a little easier to describe this histogram. So I just want to practice describing the histogram without those summary statistics. So describe the distribution of a number of dead trees. I assume that you've already read this and tried this. If you haven't, you should pause the video and do that. The very first thing you want to start with is saying the distribution of the number of dead trees. So like that right there in itself is probably enough to get a partial. That's because I want to make a big emphasis on that. That's what I mean when I say include context. So you should just start with that statement. So probably the first noticeable thing is that it's right skewed. Maybe strongly right skewed. There's a gap in the 12 to 14 bin, which I guess would be the 12, 13, based how the bins are defined. But there's the gap within there. And a possible outlier. At 14 to 16 bin. With a center, now you can determine if there's 75 blocks. The center is going to be 75 plus 1 over 2, which would be 30, which would be the, let's see, 76 to 38th. The 38th position. Now it looks like the height of this bar is about 38. So I'm going to guess the center between 0, and 2, which again, based on how the bins are defined, it would be either 0 or 1. Now, I'm trying to ignore currently this, but this median is 1 justifies. So if you're given summary statistics, you could just use that median as 1. Or you can define the center. Since you have the mean, you should define the center with the mean. And then lastly, we have variability with a center between 0 and 2 dead trees. Put a little more context in there, and a spread. Now, I wanted to include a histogram for spread because students will often get this idea wrong. There was an AP classroom assignment where students said the range is 16. The problem with saying the range is 16 is we don't know for sure that there are any at 16. We don't know even if there are any of these blocks that had 0 dead trees. So yeah, sure, at most it could be 16, but the minimum the range would be 14 minus 2 is 12. So we should say we have a spread at most 16 and at least 12 dead trees. You could also say that as a range between 12 and 16 dead trees. So that's how you describe the distribution. I'm pretty confident that this year you will be given a graph and you'll be asked to talk about it. That's really common. It's a kind of an essential thing in the AP Stats world. Don't know what graph it might be, but as we do these mock exams, you'll see different types of graphs. Sometimes I'll ask you to make your own graph. Other times you'll be given a graph. But the way that this one would be scored, so you can score your own paper, make sure that you mention the number of dead trees. Make sure you talk about the shape. Something like including the gaps and the outliers would probably be like a thumbs up. Make sure you talk about the center, and make sure you talk about the spread. So maybe the scoring guideline would say if you have those 4 things that I've highlighted, you would get an E. If you had 2 or 3 of those 4 things, you would get a partial. And maybe you get an E plus, a thumbs up, something to note for later, if you mention the gap and or the outlier. But on this one, the biggest concern I would have is when you talk about the center and when you talk about the center and the spread with a histogram, you can't know exactly where the center is or exactly what the spread is. I mean, unless you have a histogram where 1 bar is just 1 value. This 1 bar is all the 0 case. This 1 bar is all the 1 case. I should mention, I mean, we've been ignoring all of this. Now, if you were given output like that, you very well could just state the center is at 2.36 dead trees, and the variability, the spread, the standard deviation is 2.883 dead trees. You'd still have to mention the shape though. Okay, so that was the first part. The next part, interpret the standard deviation in context. So hopefully you're familiar and you remember what the standard deviation is and how to interpret it. That would be an example though of something if you had on your 1-page sheet, then you can use that to help yourself out. But again, I'd encourage you not to rely too heavily on the 1-page sheet because that's a lot of valuable time that you might be wasting. So interpret the sample standard deviation, we'd say on average, the number of dead trees in a block. Typically varies. Kind of like the word typically there. Put that away. Typically varies. And typically is I kind of already addressed with on average, but got to go overboard. Typically varies by 2.883 dead trees from the mean. And I'll even include the value of the mean there, just for a smiley face plus. So in this question, you'd want to mention something about that this is an average distance, an average distance. Again, you'd want to mention that you have context. Want to talk about the number itself, and you want to talk about variability from the mean. So some students on past questions would kind of stop by saying on average the number of dead trees in a block typically varies by 2.88, and we don't know what it varies from, so it's important that you say it typically varies from the mean. Whether you include the value of the mean usually isn't in the rubrics, so I just include that. Next question. Name the sampling method used by the citizen to estimate the number of dead trees. Describe the advantage of this method of randomly sampling city blocks over a simple random sample of homes. So we know the answer is not simple random sample since we're asked to contrast it with simple random sample. So our options we have are cluster sample, stratified, or systematic. Let's start with the bottom and go up. So it's not systematic. They didn't have a list or number all of the houses in some order and then take every 10th house or every 20th house. So they didn't do that. So it's not systematic. Stratified sample. Now they did separate the population into blocks, into like regions. But to be stratified, you'd have to take some elements from all the groups. They did not sample that way. They actually took some of the groups and selected all of the elements. So we would say this is a cluster sample. So it says name the sampling method. So it's cluster. Some clusters, which were the blocks, selected at random, and all houses surveyed on that block. It doesn't say to justify, but I'll include a justification that it's cluster and not these other two. And then it says give an advantage of this sampling method. So you can imagine the problem with a simple random sample. If you've numbered or all the houses, you might have to like geographically travel from one part of the city back and forth and back and forth. A cluster sample is much more efficient. It's easier to obtain. It's much less traveling. We'll say traveling all over the city. Like you would with a simple random sample. So typically that's a benefit of cluster sampling, especially if the clusters are naturally occurring clusters. And it's not difficult to form the clusters. But the natural benefit of cluster is once you've selected your cluster, you could just survey everyone or everything in that cluster, and it's much faster, easier to obtain. Guessing if this was a question on the AP exam, you would need to say cluster, and you would need to say the advantage of cluster. So maybe if you just said cluster, but not a very good advantage, not well articulated, you might get a partial. I'm guessing if you said stratified or systematic, you probably would get no credit at all. But those are just some ideas. Let's move on to the next part. Estimate the probability a randomly selected block in the city will have less than 6 dead trees. Now, the AP exam and College Board has been very clear that the questions you'll be having are integrated questions. So in the first two parts, we were doing stuff from Unit 1, Chapter 1. And then this part, we were doing stuff from our Chapter 4, Sampling and Experiments. Now we're talking about probability. So one way to assess how well you know statistics is how well can you jump back and forth from different topics. This is another reason why you don't just want one big, flipping through your notes, because that would take a lot of time to flip from probability, what chapter was that, and then you're going to sampling experiments, what chapter is that. So I really encourage you to make use of this review time that we have to know the content as well as you can and not overly rely on your notes. But what's the probability the block will have less than 6 dead trees? So if we go back here to our histogram, we already estimated this 0 to 1 here would have 38 blocks at 0 to 1 dead trees. The next one I'm going to say is about 20. So that's 2 and 3. We want less than 6. So this bar right here would have the 4 and 5 in it. And I'm getting those again from how the bins are defined right here. That last one, I think might be 6. So we have 38, 20, and 6. Those are how many blocks. Add those up. That's how many blocks out of 75, as they said right here, out of 75 that had less than 6. So we had the probability of 0 or 1. That's 38. Probability of 2 or 3. That was 20 out of 75. And the probability that was 4 or 5, that was 6 out of 75. So then the probability 0 to 5, which is all less than 6, not less than or equal to, but less than 6, would be 38 plus 20 plus 6 all over 75. So that's 58, 64 out of 75. And I'm just going to leave the answer like that. There's no need to multiply that out on your calculator. That would just be wasting your valuable seconds as the clock is ticking down. I believe on the AP exam, you will see a clock, like right when you start the question, you'll see that 25-minute clock ticking down. So this is another reason why I encourage you to time yourself, just to get into that time pressure aspect, to try to manage your time well. It can be extra stress. Not only is it a high-stakes test, not only is it a high-stakes test that you have this technology issue of uploading, but you have this idea of this clock ticking down. So as much as you can do to practice those things, the less stress that you'll have on exam day. Less stress from the time ticking down, and less stress about like, how do I do this upload thing? So this is our probability. Typically on the AP exam, how these are scored. If you have the answer as a fraction, then that's good. If you just wrote it as a decimal only, you probably won't get credit for the work shown. And typically you'll want to show something like this so we know where your 64 came from. And that should make sense. If someone said 62, could that be right? Well, maybe. It depends on how they're estimating the heights of those bars. All right, the next question is also a probability question. Now, again, since the College Board has said the graphing calculator or just calculator at all isn't required for the exam, then binomial questions and geometric questions are very unlikely on this year's exam, which I think I hear a big cheer coming. But I do still want to review some stuff about binomial and geometric distributions, just because, who knows what's going to happen. And it seems like the AP exam is going to be more writing or typing this year rather than calculating. So I wanted to come up with a question about a binomial distribution. So I'll let X be the number of blocks with at least one dead tree from a random sample of 10 blocks. Is the probability distribution binomial? So not any calculations really we'll have to do there, but let's review what a binomial distribution is. To be a binomial distribution, you would have to have binary outcomes, so B in bins. Is there clearly defined success and failure? Well, success would be the block has at least one dead tree. That doesn't sound very successful, but success doesn't have to be a good thing. And then there is failure, which is not that. Should probably use words. Not having at least one dead tree. Okay, so far so good. We do have binary outcomes. Now something that wouldn't be binary outcome is like, what's the size of the tree? And if we defined X as the size of the tree, small, medium, or large, I don't know. That's three different cases, being small, being medium, being large. So that's just an example of not being binary. Independent, are the observations independent of each other? Well, technically no, because we're sampling without replacement. You have these 10 blocks. So that condition wouldn't be met. However, there is something that we could do to address that. Since we're sampling without replacement, which is really common in statistics, without replacement, we assume the population is greater than 10 times the sample. The sample size is 10, so greater than 100. That's 10 times 10. This is the 10% condition. So independence can be assumed. The lack of independence is not a problem. It's probably a better way of saying it. But we're okay with this condition being met because of the 10% condition being true. That the sample size is less than 1/10 of the population is another way of saying it. The sample size is less than or equal to 1/10 of the population size. That's the sample. Well, that's another way of looking at the 10% condition, but I usually just do 10 times the sample size, multiply both sides by 10 and that inequality at the top. And then next part, N, we have, do we have a fixed number of trials? Yes, we have N equals 10. So fixed sample size, N equals 10. And then lastly, do we have the same success probability? So up here we defined success as having at least one dead tree. What is the probability of having at least one dead tree? Well, if we go back to this histogram, there's really no way for us to use the histogram to get an estimate of that probability, given the bins are 0, one. The first bin is 0 and 1. So at least one, we have to count 1 and 2 and 3 and 4, and there's really no way of getting that probability or even estimating that probability. So that's going to be a problem. There's nothing we can do to really fix that. So no. So ultimately, this is not going to be a binomial setting. We don't know and can't calculate the probability at least one. Well, I should say the probability that a block will have a dead tree. We'll say probability dead tree. We don't know and we can't calculate the probability of dead tree. So overall, make sure you answer the question. We'd say it is not binomial. Don't let this no be sufficient for you. That's just checking a condition. We would like to know, okay, so that condition isn't met. What does that tell you? Is it binomial or is it not binomial? So this is not binomial. If this happened to be a question, probably all you'd have to do on questions like this in the past, all you'd really have to do is, if it's not binomial, give the reason why it's not binomial. All of this up here is just extra stuff that I wanted to do to review. Now, if it was binomial, you'd have to do all 4 of those. But in this case, since it's not binomial, you could just do that last S of bins. Okay, for further analysis, the concerned citizen is considering creating a 95% confidence interval to estimate the average number of trees. So we have an interval. We have a 1 sample interval for an average. This would be called a T interval, or a 1 sample T interval. Not that you're asked that, but that's what it would be called. Are the conditions met? So we have a random sample. Of 75 blocks. The next one, we checked the independent condition. We assume there are more than 10 times the sample size of 10. In the population. That seems like a fair assumption. We were told there were thousands of blocks formed. So that seems fair. And then the last one's the normal condition. For the normal condition, I guess I need to do a little rewording of this question, I guess. Since it might be a little confusing with the 10 blocks. So I'll update this question so it says 75. So in that case, let's say we're taking a sample of 75. In that case, we'll adjust this a little bit. There we go. And then for the normal condition, we'll say since 75 is greater than or equal to 30, based on the central limit theorem, the shape of the sampling distribution of X bar will be roughly normal. So if this were being scored on the AP exam, you'd want to mention that you have a random sample. You'd want to check the independent condition, and you'd want to say roughly normal, because 75 is greater than or equal to 30. Things that can give you smiley faces. If you identify the correct distribution, sampling distribution of X bar. Now, if you put p hat there, that's going to hurt. If you put sample distribution, that's going to hurt. It's a sampling distribution. If you mention the CLT, that would be a good thing to do. We only use the central limit theorem with means, just as an aside. If this had been a Z interval for a proportion, then we won't do the CLT, not the CLT. we would do n times p hat is greater than or equal to 10, and n times 1 minus p hat is greater than or equal to 10, if it were with proportions. So this question had 6 parts. A lot of teachers in the AP Stats community are conjecturing that the first question will have 6 parts based on how the breakdown is. The last thing I wanted to mention to be careful about that I forgot earlier is this question. Even though we're taking blocks in a city, those are city blocks. So this is not a block design. Randomized block and statistics is different than a city block. So just be careful about that. I believe that is it for that first one. And we will continue in a separate video looking at the second question. Thanks for watching. And if you liked, give me a thumbs up. And hey, you can subscribe too.